Algebra 1, Common Core, Unit 3, Section 3, Basic Trinomial Factoring. So in the previous video, 3.2, we learned about factoring a difference of two squares. Difference of two squares factoring was something like when we saw x squared minus 4. And that factored to a product of two binomials. One was x plus 2 and one was x minus 2. Well, what we're talking about in this video is kind of related to that. So I'll refer back to this later. But what we're talking about factoring trinomials, now these are basic trinomials. And what we mean by basic trinomials is that the coefficient of x squared is 1. So remember, we see no number in front of x squared. That means there's a little invisible 1 there. You could always write the 1 in. But that's what we talk about basic trinomials. When you start to see numbers in front of x squared, those were what we call advanced trinomials. And we're going to talk about that in another video. So we're just talking about basic trinomials today, just getting started with the basic stuff. And trinomials, they're called trinomials because they have 1, 2, 3 terms. The numbers that go in front, again, we know there's a little 1 there, we call that A, the middle number we call B, and the constant on the end we call C. So it's like an A term, a B term, and a C term. The A term is with the x squared. The B term is the middle x term, and the C term is the constant. And the basic trinomials, if they're factorable, which these will be since that's what we're practicing, but you will come a time when you don't have factorable things and you got to do something called the quadratic formula, but that's chapters from now that we don't need to worry about. So basic trinomial factoring, first of all, we've learned two methods before this. We learned GCF factoring. Oh, hold on. Let me fix that. We learned GCF factoring, and we also learned difference of two squares factoring. So one of the skills you need to develop here is recognizing when to do which one. Now, trinomial factoring, first of all, you see that there's 3 terms. So that's a big hint right there. But we did have GCFs that had 3 terms. So we do need to rule out GCF before we do any trinomial stuff. And so you got to look and see, is there anything that we could divide everything by? Is there a GCF? And you look at this one, for example, x squared 6x plus 8. We can't take out an x because the 8 doesn't have an x. And I can divide 6 and 8 by 2, but not the one that's in front of x squared. So there is no GCF. And it's not a difference of two squares because it's not 2 terms, it's 3 terms. So you can tell right away that it's not a GCF. I mean, that's not as obvious, but you can kind of see that there is no GCF. But you can tell right away that it's not a dots because there's 3 terms. Similar to a difference of two squares, we factor to two binomials. So you see all of these factor to a pair of binomials, a pair of parentheses. And again, you kind of see a pattern. So like for the difference of two squares, we thought a lot about square root stuff. Well, we're not going to talk about square roots here. The numbers that, now, first of all, they're all going to lead with x and x. So every trinomial basic factoring starts with, like if I get ready for this one down here, x and x. So that's the case for every problem on this page. But the numbers and the signs that go in there, they depend on what your B and C terms are. And the directions tell you how to do that up here. That you're looking for two numbers that add to B and multiply to C. So if we look at our first example, B is 6, C is 8. So we're looking for numbers that add to 6 and multiply to 8. And it's helpful sometimes to write AM on top of it. You can always remember the time too. Like if you could, is it AM or is it MA? Well, AM is the time. Like right now, my clock says it's almost 2 o'clock p.m., but the school day started around 7:30 a.m. So AM, not MA. And if you write that on top, helps you remember what adds to 6, what multiplies to 8. Now, what adds to 6? Adds to 6, there's a lot of numbers that add to 6. I mean, 1 plus 5, 4 plus 2, 7 and negative 1, positive 10 and negative 4. So there's a lot of things that add to 6. And what multiplies to 8? Again, a lot of things multiply to 8. And it's usually helpful to first start with what multiplies to 8. Because you could think of a million things that add to 6 once you start including negatives and stuff. But multiplies to positive 8, there's only so many. And you could always kind of make this little chart on the side. What multiplies to 8? Well, of course, 1 times 8 is 8. You also got 2 times 4. And that's it for positives, but don't forget that negatives also, because a negative times a negative is positive. So negative 1 times negative 8 multiplies to positive 8. Negative 2 and negative 4 multiply to negative 8. So these are numbers that negative 2 and I don't want you to think that's negative 2 minus 4. It's negative 2 and negative 4. These are two numbers that multiply to positive 8. So these are all the numbers we could use. Which numbers from this list also add to positive 6? Well, 1 plus 8 is 7. 2 plus 4 is 6. That's what we wanted. These would add to, so they don't add to 7, they add to 9. These add to negative 9, and these add to negative 6. But this middle row right here, the 2 and the 4, those are the numbers we wanted. So that's why it's x plus 2 and x plus 4. Because positive 2 and positive 4, they add to 6 and multiply to 8. So you need numbers that do both, add to 6 and multiply to 8. The end is crucial there. And the order doesn't matter. We could write this as x plus 4 and x plus 2. The order doesn't matter as long as, the right numbers and the right signs. If you look at this next one down here, it's going to be x minus 3, x minus 4, because these two numbers, negative 3 plus negative 4 is negative 7. That's what they add to. And they multiply, negative 3 times negative 4 is positive 12. They multiply to 12. Down here on the third example, this should be example 3, numbers that add to negative 3 multiply to negative 10. That is negative 5, positive 2. They add to negative 3 and multiply to positive, they multiply to negative 10. It should be negative. So that's the pattern. That's what you're looking for, and that's how you're going to determine your answer. So let's look at a couple fresh problems. So for this first one, similar. It's actually the same exact question that we have up here. So x squared plus 6x plus 8. What multiplies to 8 and adds to 6? Well, we already talked about it. It's 4 and 2. X plus 4, x plus 2. Because 4 and 2, positive 4, positive 2, multiply to 8, add to 6. And how about this second one here? What multiplies to 10? So there's only so many numbers that multiply to 10. And it adds to positive 11. See, it's helpful to know, what, again, like I said, start with what does it multiply to? But then you can say, all right, if it multiplies to positive, then I know they need to be the same sign. All right, like we're going to see questions down here where if they're multiplying to a negative number, now I'm looking for numbers with different signs. But if I'm looking for numbers that multiply to the same sign, multiply to positive, they got to be same sign. So let me write that. If C is positive, that means the same sign. And so that's the case here. I'm looking for numbers with the same sign. I'm looking for numbers with the same sign. But that could be, both positive or both negative. So how do I know if I'm looking for two positives or two negatives? Well, look at what they add to. Because two positive numbers add to something positive, right? 1 plus 4 is 5. And two negative numbers add to negative. Negative 1 and plus negative 4 is negative 5. So if they multiply to the same sign and add to positive, then you're looking for two positive numbers. If they multiply to positive but add to negative, like this example down here, well, that means I must be looking for two negative numbers. Because if they multiply to the same sign, they multiply to positive, but they add to a negative, they must be both negative. And that's helpful sometimes in figuring that out. And then when you see down here, anytime C is negative, so if C is negative, you're going to have both signs. You're going to have one positive and one negative. So automatically, anytime I see a negative there, I know it's going to be x plus something and x minus something. All right, so that's helpful, I think, in figuring these things out. Let me stick with green here. So what multiplies to 10 adds to 11, x plus 1, x plus 10. 1 times 10 is 10, 1 plus 10 is 11. How about this third one here? What multiplies? So first of all, multiplying to positive, so the same sign, and adding to positive, so they're both positive. Multiplies to 14, adds to 9, 7, and 2. 7 plus 2 is 9. 7 times 2 is 14. Like I said, it may take a little bit of practice. You may need to say, all right, 14. What multiplies to 1 and 14? 2 and 7. Oh, these add to 9, so there's my pair. And so you might have to kind of do a little trial, a little scrap work on the side sometimes. That's okay. Now, let me go down to this one that I started. So this one multiplies to positive, adds to negative. That means they must both be negative. And so what multiplies to 18? 18's got a bunch. But I know I'm looking for two negative numbers now, which is really helpful. -1, -18. Does that add to -11? No. -2, -9. Does that add to -11? Yes. So x minus 2, x minus 9. And there were more. We also think, -3 and -6. But that adds to -9, not -11. All right, and let's see here. How about this one? Again, multiplies to positive. So it multiplies to positive 15. So 15, I think the first thing people think of is 3 and 5, right? But I need them to add to a negative. So how about -3 and -5? X minus 3, x minus 5. Another one over here. This is multiplies to 6. 6 is an interesting one because like sometimes it's 1 and 6, sometimes it's 2 and 3. But again, I need to add to negatives, so I'm looking for negatives. And I'm looking for the pair that adds to -5. There it is. X minus 2, x minus 3. Remember, you're welcome to, at any point, to pause a video. Once you think you got it, pause it. Try them yourself. Do the work in pencil or on a separate sheet of paper, and then play the video and see if you got them right. All right, so here we talked about if C is negative, if the last number is negative, we're looking for one of each sign. So right there, that -10 multiplies. That means I'm going to have a positive and a negative. It adds to -3. And this is one where people tend to mess up the signs of things. So I'm looking for something that multiplies to -10. That's going to be +2, -5. But remember, I could also have the same numbers the other way, meaning it could be a -2 or a +5. These multiply to -10, these multiply to -10. Which pair adds to -3? And remember, if you're adding different sign numbers, whatever sign they add to, that's got to be the larger one. Because like these, for example, like 2 positives and 5 negatives, there's more negatives in this pair, so it's going to add to -3. This one's -2, +5. There's more positives, they're going to add to +3. And since I add to -3, it must be the x minus 5 and x plus 2 pair. And real quick, I'll just throw these answers down. I think you're probably, getting it at this point. Multiplies to -21. You probably think it's 7 and 3, but they got to be different signs. And there's two different ways to do that. It could be a -7 or it could be a -3. Well, I need to add to a +4, so I need a positive to be larger. So x plus 7, x minus 3. And the last one, kind of running out of space here. Ooh, that's kind of funky. Let's go back to a regular pen. Multiply to negative, so it's going to be 1 plus 1 minus. Again, the order doesn't matter. But adding to negative. And so -12, I can do 6 and 2, but it's going to be 3 and 4 because they're 1 away from each other. Remember, there's a -1 in there. But they're different signs. So which one gives me adds to -1? So I need more negatives. So that bottom group right there, x plus 3, x minus 4. And just like we do with all these other things, it's reverse distribution. If I distribute these, I'll come back to this. Remember, when you got to distribute, you got to do FOIL and be careful with your distribution. I was going to refer back to the dots, because what we could say is you could think of x squared minus 4 as x squared plus 0x minus 4. And numbers that multiply to -4 are 2 and -2. It's just like we were thinking about the square root of 4. And they also add to 0. So it does kind of connect to that. But just remember the AM, and remember if they multiply to positive, they're the same sign, and then you can figure out if they're both positive or both negative. But if they multiply to a negative, then you automatically know it's a different sign situation. All right, sorry the video's a couple minutes longer today, but it was a lot to talk about. So that's basic trinomial factoring. See you.